Okay, guys, let's see. Did you get the derivative of fx equals 3x? Well, what does the rule say? What's the derivative of a straight line? What's the gradient of a straight line? Is very simply the coefficient there. So f prime x is equal to 3. This one's a little bit of a challenge here, the hyperbola. Okay, so let's go back and quickly check. What do you notice with this one? You bring down the 2, that exponent 2, and subtract 1, and the derivative of the number is 0. Okay, and that's important. And then, of course, with this one, the gradient was, of course, 3. But now what about this one? This one's a little bit sneaky. Remember, we want things to look like this. This is important. Watch this. You want it to look like ax to the n. But this is a problem. Now, that's an exponent 1. Now, do you remember from the rules of exponents, x to the negative 1 was actually 1 over x, if you remember that. So what I'm going to do is I'm going to apply this. So I'm going to first say, now, I'm going to say, therefore, fx is equal to x to the negative 1. And there's a little imaginary 1 there, but don't worry, it's now of this form. Okay, now that's important before you differentiate to be able to do these things. Now notice my notation. If you look at this, it's still fx. It's not f prime x yet. But when you are ready, when you're in that form, you can now say, therefore, f prime x is equal to, now you bring down that negative 1, and you keep that exponent, but you always subtract 1, and that gives you f prime x is equal to negative 1 x to the negative 2. Now what we could do is we could leave the exponents as positive. Now how do we do that? Well, very simply put, you can keep the minus 1 on top and drop that guy down, and you've got the gradient there, or the derivative, using this rule. So that's quite important. Watch out for that notation as well. Okay, I cannot emphasize the importance of notation, because you will lose a lot of marks if you don't focus on what I'm showing you now. Okay, let's have a look at some more of this. Okay, now different notations. This is so important, people. Matrix, all over Mzansi, you need to be listening, because many of you lose your distinctions or you lose your passing because your notation is not good. So stay tuned. We are going to perfect this. Everyone in the nation do this. Let me see. Yes, are you connected? We're going to get there. All right. Alien Phillips to the nation. Focus. Come with me. Here we go. 2 slide. Yeah. Very important. Look at this. fx is that we want the derivative. Now, important, remember, we want, what do we want? Something x to the something. So this divide by 3 is a problem. So what do we do? The very important thing that I'm going to do firstly is I'm going to make this 1/3 x cubed. Remember, there's a little imaginary 1 here. So what you could do is you can make, you see, x cubed over 3 is the same as 1/3 x cubed, ax to the n. Now, once you're in that form, we can now say, okay, the derivative is going to be, now watch this, 1/3, keep it there, times, bring that exponent down, and subtract 1 from the original there. The 3's cancel, and f prime x is equal to x squared. And remember, I always like to put little therefores there. Okay, now, and there's your gradient. Okay, so watch out. When you've got fx equals, now this is important, fx equals, you first get it in the form ax to n, so it's fx equals, and then when you're ready to apply the rules, you then put f prime and you drop it. But notice in the second line, you're not writing f prime, you're only reorganizing this thing. Okay, then you apply the rules. Okay, that is so important. All right, now what about this one? If they say y equals, now again, please watch what I'm showing you here. You write y equals 1/3 x cubed. You first organize it. It's therefore y equals. This is so important, people. You need to get this right. Now, the symbol we use here is not fx or f prime x. If they're using y, what we can do is we can say the symbol little dy over dx, small letters, equals. Then you apply the rules. 1/3 times 3x squared. Therefore, dy over dx is x squared. Be very careful. If it's fx equals, y equals, we go y equals, fx equals, get them nice. Then you go f prime or dy over dx equals. Notice where the equal signs are. That's so important. The equals are there. And notice the notation. Okay, please, guys, it's important that you see that. Very important. Fx, f prime, y equals, that's not nice. It's not in the form we want. You wanted ax to the n, something x to the something. Then you go therefore, and then you are able to deal with that. Okay, so important this. Now, the other notation that they could use is this. Now this you must watch out for because many matrics get this wrong. There's no equals there. Okay, so we introduce an equals now, and the equals is on the left. Watch this. This gives me equals. That's important, but you can't, this says do it to x, differentiate to x. So we go like this. Okay, now notice it's dx equals, it's equal to dx of that. Then when you apply the rule now, you then drop the dx like you do the limit. So you go 1/3 times 3x squared is x squared. Notice this notation. Very important matrics. Please don't mess up or lose marks on silly notations. Stay with us. After the ad break, we continue with rules of differentiation.